Okay, write down the angle that represents the angle of elevation of the top of the wall. Top of the wall is here. Then from the man's head. So the man's head is here. Okay, elevation means going upwards. So it's always measured from the horizontal. So it's this line that is parallel to the ground. Okay. So from the man's head, head is here ma. So there is a line that is parallel to the ground. Parallel one. Then the angle that is going up towards the wall. The wall from the man's head. So this angle is the angle of elevation between the horizontal and towards the wall. Can? So question part A, they are expecting you to say the angle is angle B, because this is the angle of elevation going upwards one from the head towards the wall. The wall is above the head, so this one is the angle of elevation. Elevation means up. Angle of depression of the man's head from the top of the wall. So it's the same thing. The two objects are the same, the man's head and the wall. But remember, this one is from the top of the wall, so it's from here, coming here from here, because head is lower so it's from here, depressed, I go down. That's why this angle, again, it is measured to the horizontal. Then this is the angle of depression, because it is measured from the horizontal, then going downwards towards the head. So angle C is the angle of depression. Depression going down. Can? Okay. Then calculations. Car C is parked 150 meters away from the building. Building AB. So this one is the height. So same they expect you, or they also draw for you, this is 90 degrees. The height is always 90 degrees to the horizontal. Okay? Find the distance BC. They tell you this building how high, they tell you this distance. So we have a right angle triangle, we are finding distance, so Pythagoras. Can? Right angle triangle here. Okay, so angle of elevation, angle of depression, always a lot of 90 degrees, a lot of right angle triangle. You will be expected to use a lot of Pythagoras and Picasso. Okay, distance BC. Pythagoras, I don't really remember by the A, B or C one. I remember by longest. The longest side square is equals to the other two sides square and added together. So this one is the longest. So longest square is the other two square and added together. The two shorter side, which one come first, which one come behind, never mind one. Just that the longest side is always special by itself. Okay, I think it's easier to remember like that, instead of remembering A, B and C. Then I want BC, I don't want it being squared, so I need to square root both sides. Okay, so this is, if you know a bit of your algebraic manipulation, you form equation already. From BC square you want to become BC, you square root. Then because I square root the left, I have to square root the right. So if you know a bit of your algebra, this equation become very easy to remember. Okay, then calculator. Okay, go and practice pressing your calculator also. How? Practice pressing also. Because where you add the bracket or how you press, make sure that your square root cover everything. All this is part of the skills that you will require. Okay, do you get 161.5549? Wait, you all never even take out your calculator. Pressing your calculator is part of the skill you require. Okay, then it is not an exact number. So for an answer, we can round it off to 162 meter. 3 significant figure. To round off 3 significant, 1, 2, 3, I look at the 4th significant. 4th significant, 5 or bigger, means my 3 significant here must round up. That's why it become 162. Angle of elevation of the top of the building from the car. So car is here. Top of the building is here. Building from the car, then measured from the horizontal. So they are asking us for this angle, ACB. Okay, so they are asking us for this angle, angle of elevation. Here, then from here, from the horizontal of here. So this is the angle that we are measuring. Okay, this rotation. How much is this rotation? We have 60, we have this 150, then we want angle. So, right angle triangle, Pythagoras or Tuakaso. Angle, so Tuakaso lor. Then this is the angle. Then I must look at this side that are given. How are they? What are this angle in relation to this angle? Sorry, what are these two sides in relation to this angle? So if this is the angle, 150, this side is touching this angle. English word adjacent means side to side, side by side. So adjacent means this 150 touching this angle, it is side by side with this angle. My 150 is my adjacent when I'm looking at this angle. Then opposite 60 is my opposite of this angle. Okay? So to find out more about this angle links the opposite and the adjacent. I need a ratio of this angle that links opposite and adjacent. Then I look at my Tuakaso. O and A, opposite, adjacent. So tangent. Tangent of this angle is the ratio of opposite over adjacent. So for part B, I will write down tangent of this angle. You can name this angle angle C lah, since it's at the C. Tangent of C is equals to opposite over adjacent. Opposite is 60, adjacent is 150. Then I want to find C. I am finding angle. So I want the C. I don't just want the tangent. The tangent is this ratio. But from this ratio, I can find back the angle. Because if I want C, I want to cancel away the tangent, I need to tangent inverse. When I tangent inverse the left, tangent inverse will cancel the tangent. Then I can find back C already. But because equation, left and right are the same, I need to tangent inverse both sides at the same time. So my C is equals to tangent inverse 60 over 150. Again, calculator. Practice pressing. Tanya, are you following? Okay, you press calculator correctly, it will be 21.801. Okay, for those of you who want to score full marks when you write your angles or you write any answer, you will see that I leave a few more decimal first. I leave a few more significant figure first. Okay, then after that, then I round it off. Some questions they will require, is part of the answer scheme. They want to see you round off. Then you must write a few more significant figure first. Copy more from your calculator. Then round it off. Some will deduct mark if you don't do that. Okay? But one paper maybe 1 point or 2 point lah. Okay, then we still have part C. Angle of depression of the car from the top of the building. So when we are measuring this angle, car from the top, then it must be measured from the horizontal also. So from the top, there's a horizontal that is parallel to the ground. Then the angle of depression is from the horizontal going downwards. This angle. Okay? Then horizontal line, there is a Z over here. Okay? Meaning this angle is the same as this angle. Alternate angle, parallel line. Okay? So the angle of depression is actually the same as this angle of elevation. Okay? So part C, the angle of depression is also equals to 21.8. If they ask for reason, you can say alternate angle, parallel line. Can? Okay, next. Part C, question 3. The diagram shows a vertical pole AB with a height of 8 meters. AC is 13, CD is 5. Here is 5, here is 13. Okay, angle of elevation of A from C. A from C, so from the horizontal of C going to A. So the first part, they are actually asking you for this angle. From horizontal of C towards A. This rotation over here. Okay? Then, like I say, elevation. There are right angle triangles. So, the right angle triangle that can help me find this angle is the right angle triangle ABC. This inside one. Then this inside one, I know this is 13. I know this is 8. 13 is the longer side. Longer side is always the hypotenuse. 8 is opposite my angle. Okay? It is all in relation to my angle. My angle is here, so 8 is my opposite. So, tuakaso. To link opposite and hypotenuse together, I will need to use so. Tuakaso. The one that links opposite and hypotenuse together, opposite hypotenuse is sine. So sine of this angle is opposite over hypotenuse. So part A, I know that I have to use my tuakaso. I know that I have to use the sine. So sine of angle C is equals to opposite over hypotenuse. Sine of C is 8 over 13. Then same. I want C, I must take sine inverse on both sides. Angle C is equals to 37.97987 or 38.0 degrees. 3s. Sorry. For angles, we give to 1 decimal point. 1 dp, not 3sf. Here also. Should be 1 dp, not 3sf. Your question paper at the front, they will say anything with to do with degrees, to do with angle, not exact, give to 1 dp. Can? Then B part 1. Find BC. Find this side. I know this side. I know this side. Right angle triangle. So Pythagoras. Then I remember by longest side, 13 square, is equals to the two shorter side square and added together. A square plus BC square. Then I just need a bit of algebraic manipulation. I want BC. So I move my 8 square across lor. 13 square minus 8 square equals to BC square. Then if I want BC, I take square root on both sides lor. So this one should be minus. But I don't need to remember so many forms. I just remember longer side square is the two shorter side squared and added together. It must be, cannot be the other shorter side. Right? The special one is the longest one. That still got a chance. The other two add together. Okay? Then same, press calculator. Square root 13 square minus 8 square. $10.24695. Write a bit longer first, then round off to 3 significant figures. Okay? Okay, lastly, angle of depression of D from A. So you must first know where is the angle. Okay? D from A. D from A. So it must be from the horizontal of A. So from A, I need the horizontal. And then it is this angle. Okay? So this time round, be careful. It is no longer the right angle triangle ABC. From here until here. So it is the right angle triangle ABD. AB until D. Okay? I want to find this angle. There are two ways. Actually, both are similar. One way is using the alternate angle. I want to find this angle is the same as finding this angle. Can see? Then the other way is, here is horizontal, meaning here like that is a 90 degrees. Okay? So I can find this one, then take 90 minus this one, also can. Or if I take this alternate angle, then I just find this angle D also can. So find angle D or find that one actually is still the same. Just Similar, the steps. So now I must make use of the bigger right angle triangle. Then what are the sides that I know? From the bigger right angle triangle, Gabriel, I think you all better don't sit together leh. You are passing leh, but Braden eh?
He would have passed.
He would have passed.
Yeah.
Really meh?
Yes.
Find it hard to believe. Okay, so the big right angle triangle, what are the sides that I know? I know this one. I don't know this one. Can I know this one? I can, because I have found BC. Then they tell me CD is 5. So I also know BD already lor. I take my part 1 answer, BC plus another 5, I have this BD. So with BD, with 8, I can find this angle. Because I have right angle triangle, then with respect to this angle over here, this angle over here, if I find this, it's the same as finding this alternate angle. So how do I find this? I use this side and this side. Then with respect to this angle, BD is my adjacent. Eight is my opposite if I only look at the big right angle triangle. Okay? So I'm using opposite and adjacent to help me find this angle D. Opposite, adjacent, so use tangent. Opposite over adjacent. Wow, so many aeroplane on. Okay, so opposite is 8, adjacent is BD. So when I write here, BD is BC plus 5. Okay? Then for those of you who aiming to get full marks one, don't use this BC. If I take this BC plus 5, I will write 15.2 here. Okay? But it's not so exact. The more exact BC is 10.24695, the longer one. So this one is the working. This one is when I answer questions. This is the answer. Answer say round off to 3 significant figure. But here, as a working, I want to use as exact as possible. So I will use this one. Or if you write even longer, even better. Okay? So here, instead of writing 15.2, if I take this one plus 5 is 15.2 I will take this one. I will take 15.24695 when I put it here. Because working, I want as exact or as many significant figure as possible. Then if I want D, I will take tangent inverse 8 over 15.24695. Okay? Later we try. See 15.2 and 15.24695 got different. Times 8 tangent inverse 37.97987. Then when we round off, it will become 38.0, 1 decimal point. Okay? Wrong. Did I do wrongly? 15 point. Hey, sorry. I used the wrong number just now. I forgot to add 5. Tangent inverse. I take my calculator number, I never add the 5. Tangent inverse 8 over 15.24695. 27.68577. .7 1 dp. Okay, if I never put this 0.24695, if I only put 15.2, then I will have 27.75. Okay, so this one I write in green over here. If I do tangent inverse 8 over 15.2, the answer will be 27.75. Then when I round off, it will be 27.8. Okay, so there will be a bit of difference one. If I take the more exact answer, my answer is 27.7. If I take the round off answer from here, 10.2 plus 5, then my answer is 27.8. So this one is a more correct or more exact answer than this one. Okay, so in the exam, sometimes they will only accept this answer for accuracy. Okay, so just nice, this question can demonstrate why we use a longer string of numbers instead of a rounded off answer as our working. Okay, rounded off one will be 27.8. Never round off so much one will be 27.7. Okay, can we continue? AB is a vertical pole. PD is parallel to CA. We skip 4 lah. Like not interesting leh. Question 5 more interesting, right? Got picture. Got lighthouse. Okay, Alan and Brandon are in front of a lighthouse. Alan is here, Brandon is here. Brandon is 50 meter. Angle of depression of B from the lighthouse is 48. This one they never put in. So you can add in yourself the angle of depression. So that is when measured from the horizontal here to B is 48. Okay, the height of the lighthouse if this is 48, here, like that, until here, like that, here is also 48. Can tell? Alternate angle from D until B until here. So this one is 48, this one is 48. Then I want to find the height. I know this. I want to find the height. It's either, because right angle triangle, it's either Pythagoras or Tuakaso. But Pythagoras, I need to know this one also. But in this case, I don't know this one. I know this angle. So become Tuakaso. I am using this angle to find this height. This height is opposite this angle. So here is opposite. This 50 is touching my 48. So it is the adjacent. Okay? So I need to use this relationship between O and A. Tuakaso. So Tuakaso. O and A. Tangent. Once I know that I have to use tangent of this angle, I can write down tangent of 48 is equals to opposite, which is CD, the height of the lighthouse. Okay? Height, so it is considered to be 90 degrees one. If we join C and D, we are expecting it to be a 90 degree height. Okay? Opposite over 50. Okay? Once I'm able to write down this relationship between the angle and the two sides, then it's a bit of algebraic manipulation again. I want to find CD. This one is a number. Tangent 48, I press calculator, is also a number. So I want to make CD the subject. To make CD the subject, I don't want CD to be over 50. So I multiply 50 to both sides. The 50 that I multiply here will cancel away. The 50 that I multiply to the left will become multiplication. 50 times tangent 48 is equals to CD. Okay, I multiply 50 because I want to cancel out the denominator. So I multiply 50 to both sides at the same time. Equation, whatever I do, I must do to both sides. So I multiply 50 to both sides. Multiply 50 to cancel. Then I just press calculator. 50 times tangent 48. $55.5306. So this is the height. Okay, 55.5. Can? Okay, then they tell you this angle between the angle of elevation is 3 degrees. So if this whole thing is 48, here is 3, means this smaller one is 48 minus 3. Okay, so this angle here is 45. 45 plus another 3, then become 48. So this angle of depression here until A is 45. Then again, I use my alternate angle like that, like that, like that, like that. I can find that this angle is 45. Okay? Now with this angle 45, I want to find what is AB, means if I can find AC, AB is just AC minus away 50 lor. Because now the question is asking me to find distance between Alan and Brandon, which is this distance. Okay? So now, I know that my job is to find AC. Then how do I find AC? Again, I go and look at this right angle triangle. I want to find AC. AC is now the new adjacent. AC is now the adjacent. This whole thing. Okay? Then out of the right angle triangle, what can help me find AC? I still don't know the hypotenuse. But now I know the height already, where I found just now, 55.5. Okay? So I can use this 55.5 to find my AC. Because 55.5 is the opposite of 45. AC is the adjacent of 45. Okay? So again, opposite adjacent, they are linked by tangent. Then I can write down the new one. For part B, tangent of 45 is equals to opposite, which is my 55.5306. Again, I use the longer number. Divided by AC. Okay, once I'm able to form this equation, again it is a bit of algebraic manipulation. This is a number. This is a number. I want to find AC. So I want to find AC means I want to make AC the subject. I don't want AC to be denominator. I want it to be by itself on one side as the numerator. So equation left and right same. I don't want this in the bottom. Means I want to multiply AC to both sides. Okay? Once I multiply AC to both sides, I will have AC multiply tangent 45. Right hand side become no AC already. Because the AC that I multiply to the right will cancel away. Then AC multiply a number, but I only want AC. So I have to divide tangent 45 on both sides. Once I divide tangent 45 on both sides, right hand side still got this 55.5306. Then I divide it by tangent 45. Then the left hand side one, I divide by tangent 45, it will cancel away. So I'm only left with AC. Okay, this part, this algebraic manipulation, a lot of students always get it wrong. They don't do it one step at a time. They suddenly just change AC to the here. Then this side, they terbalik. They will take tangent 45 divided by 55.5306. So this one do slowly. Bring your AC to the numerator, then divide both sides. Do it step by step. Don't make the same mistakes. Because it's a bit confusing. From denominator, you want to make it the subject, it must go to the numerator. So do it one step at a time. Okay? Then if you can write this down, now it's just pressing calculator. This divided by this is just a number already. Okay? You should get the same answer. Okay? Then finally, when you want to find the distance between A and B, because this is not the final answer. The final answer is AB, distance between A and B. So we have to take 55.5306 minus 50 equals to 5.5306 equals to 5.53. Three significant figure. Okay, for those of you who are wondering how come 55.5306 divided by tangent 45 is still 55.5306. If we look at the picture, then let me draw this. Here is 55.5. If this angle is 45, means this angle is also 45. Okay, 90 degrees divided by 2. So this is actually forms like a square like that. The only time when this is 90, this is 90, this length must be the same as this length. Okay, anything that is 45 degrees is this same as this. Ethan, you just reached school Okay, Ken? You missed so much already, Ethan. Yeah. Can you go back, watch the videos, catch up on your own? Your job coming to school is to learn. Not necessarily you can get full marks, but at least you must learn and improve. Okay. Oh yeah, I keep talking and y'all no chance to do because y'all should have done all this already, right? Okay, we go to simple 3D problem lah. Okay, for 3-dimension problem means there is a length, there is a breadth, then there is another height one. So it is solid, got object one. It is no longer for like bearing. Bearing, we're looking from the top. Everything is considered flat. Then elevation and depression, we're looking side view. Also, everything is flat. It is just up and down. But now when we have a 3D, there is a depth, there is a thickness. Okay, so we must remember, still everything that is standing upward is 90 degrees. Okay, so if we take a look at this cuboid, AB is 4, BC is 12, then CG, the height is 8. You want to find the length of diagonal AG. A to G. So A to G, we must be able to imagine if we just looking at the point, where is the 90 degrees? Okay? Because I want A to G. I want to form a right angle triangle. Because got right angle triangle, then I can use my Pythagoras. So A and G. How can I make a right angle triangle? One way is G come down to C. G to C is 90 degrees to the flat ground. So GC is 90 degrees to CD. GC is also 90 degrees to CB. Everything that is flat on the ground, GC is 90 degrees. So from there, if I want a 90 degrees towards A, then if I form one more line over here, if I join A to C, because A to C is also flat on this ground, GC will also form a 90 degrees with my AC, because AC is flat on the ground. Then GC will be directly going upwards from point C. So CG forms a 90 degrees with AC. Then this will actually form a right angle triangle already. A flat right angle triangle. So my aim is to make a 3-dimensional problem a 2-dimensional problem. I'm trying to make things flat. Okay, this AC that is on the flat ground with this one that is going directly upward, then if I join G to A, I will actually have a flat right angle triangle. Okay. So whenever we have a 3-dimensional problem, we are trying to break it down and find a flat, make it a 2D problem. Okay? Then if I want to find this diagonal distance, I know this 8. Then if I can find AC, I will be able to use Pythagoras. Because this side, this is the hypotenuse. Can imagine? Okay? You all don't have D and T already, right? Because D and T, people, they are more able to visualize all these 3-dimensional problem. Finding if I can find a box. Okay, it's like having this box over here. Then between this point and this point, I want to make it a 2-dimensional problem. Then I must find this line from this to this opposite. So I want to find this line. It is actually a right angle triangle between here, here, and here. Okay. If you all cannot, then later you all pass this around. Go and try to visualize one corner, this corner, and then this top corner. Okay? Okay. Then I want to find your workbook. Use the top, but I prefer to use the bottom because bottom is flat. Okay? So for my one, I will find AC first. AC is the hypotenuse between right angle triangle ABC. Flat on the ground, ABC is a right angle triangle. So I will find AC first. AC square, the longer side is equals to the two shorter sides square and added together. Okay? So AC is square root 160. Then after that, in this right angle triangle, ACG, I can find AG. AG square is equals to 8 square plus AC square. AC is square root 160 ma. So AC square is 160. Okay, here square already is 160. Then AG is square root of 8 square plus 160. $14.96666. Okay, so the first right angle triangle I use is this one that is flat on the ground. Then the second right angle triangle that I use is this one that is vertically from the ground. A right angle triangle that is vertically from the ground. Okay, like that. Yellow one is like that on the ground. Then the blue one is like that from the ground. Okay? Okay, then you all go and try lah. Okay, practice 1.3. Or we do one first, then you all try. We do one first, ah. Question 1. P, Q, and R are points on a flat ground. So the first part is like a bearing problem. The bearing of R from P, 72. Bearing of Q from P, 111. Find the bearing of P from Q. So bearing from Q means from the vertical or from the north of Q. So from Q I must draw this north. Then what I'm finding, P from Q is from north turn until from north from Q turns until P. This is the bearing that I want to find. Okay, then if you still remember bearing, sometimes instead of finding this one, it is easier to find the inside one. Then take 360 minus the inside. So this time round also same. North, north. So there is an interior angle. This one is 111, means this one is 180 minus 111. Can see? Interior angle. Okay, here, 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 parallel. This angle plus this angle must equals to 180. Okay. So for part A, first I find this angle. 180 minus 111 equals to 69. Then this one will be 360 minus 69. Okay. Bearing of P from Q is equals to 360 minus 69. Can? Eh? Hey, this one nothing to do with three-dimensional. Oh. Why? Why they put this question here? Okay, find angle QPR. QPR. This whole thing is 111. Here is 72. So you can find this angle also. This angle is the difference between 111 and 72. Okay. So B1. Angle QPR. QPR is this angle. This angle is the difference between 111 and 72. QR, the side. Okay, if I draw the triangle out, P, R, Q. I know this is 19. I know this is 15. I know this angle is 39. I want to find this side. Triangle, finding a side. No right angle triangle. I cannot use Tuakaso. Then I think, can I use sine rule? Sine rule, I need to know a pair, the angle and the opposite side. But the only angle I know is 39. So I cannot use sine rule. Cannot use sine rule, use what?
What?
Not listening.
But the cosine rule.
Use cosine rule. Okay? So for part 2, the only way I can find this QR is to use cosine rule. Cosine rule says that A square equals to B square plus C square minus 2BC cosine A. Okay? When I know I need to use cosine rule, I go back to the front of the page, find this formula which is given. Then the difficulty is putting in the A, B, C and the angle. But in this case, I know there is only one angle. So this angle must be here. Okay? So I can only put in my angle here. Then if this angle is big A, that means the opposite side must be small a. Because A and A, that is the only relationship that is the most important here. This angle means that the opposite side must be this small a. So this one is actually QR. Because this QR is opposite 39.
There's not even a right angle here.
Then my 15 and 19, they are the B and C already. I just need to put them in. One of them is B, one of them is C. B and C not important. Which one is B, which one is C? Because of their position inside the formula. B and C doesn't matter one. You change 19 and 15, 19 and 15, is no difference to the calculation. Okay? Then I want to find QR. I take square root of this whole thing. Then press calculator, you can get your answer. Okay, then the last one, area of triangle QPR. QPR, area of triangle. Don't have right angle, don't have base and height, means half AB sine C. Okay, you only have one angle, so your A and B must be the sides that sandwich. Half AB sine C. Your angle must be 39. Then your A and B must be these two sides. 15 and 19. Answer. Okay, you all go back if you can. Try question 2, question 3. Question 4. 2, 3, 4. Okay? Then next lesson we go through